Hey, AP Chemisters, this is Mrs. Medaway bringing you the last blank wall for Chapter 4. This is kind of an important section. It could easily be on the AP test. It's certainly one of their standards. And this is all about oxidation reduction reactions. If you go back and remember what we talked about in an earlier section, there were several types of chemical reactions. We have synthesis, we have decomposition, we have single replacement, we have double replacement, we have combustion, and here's another type. This is oxidation and reduction. And actually, some of those, the decompositions, the synthesis, and the single replacements, and the combustions all fall under oxidation and reduction reactions. So what is this all about? You may have heard about things being oxidized before. And that terminology came from, the old times. They really didn't know what was going on, but they knew that rust or iron was changed by oxygen. So they say that iron was oxidized, all right, without knowing what was going on chemically. They just realized that rust was formed when iron and oxygen reacted, all right? So they didn't know what was going on, so they called it oxidized. Well, since then we have something called reduction as well, and that's the opposite. You can't have oxidation without reduction, okay? So what is this? Leo goes grr. Please learn that, memorize that, so you can sound like a pirate. Grr, grr, all right. I think last week was Pirate Week, but anyway. So Leo is loss of electrons, lose electrons. That means electrons are going to be on your product side, okay? Gain electrons is reduction. So that means electrons are going to be on your reactant side. You might want to jot that down if that helps you. So what does this mean? That if you lose electrons, oxidation, the loss of electrons, your charge is going to go up, all right? Why is that? If you lose electrons and you have more protons than electrons, the charge is going to go up. Oxidation, reduction, the gain of electrons, you're going to add more electrons, so your charge will go down. And then what's an oxidation number? It's the assigned charge of an atom. Now be very careful. There is the charge and there's an oxidation number. And there is a slight distinction between the two. All right, if you were to write a charge, you would write it like this. So here is the iron with a charge of 2+. So I would write that with a charge. If you want to talk about an oxidation number, which is right here, the assigned charge of an atom, this is how you would write this. What is the difference? It's where you put the plus. So a charge is officially written with the plus after the number, or and it's maybe a minus if I was talking about oxide or something. An oxidation number has the plus or minus before the number, all right? So it's different. So an oxidation number is a man-made assignment to see really who has control or which element has control of the electrons in a sense, okay? And that's starting to sound a little bit like electronegativity, isn't it? And so we're going to use that idea of electronegativity to assign oxidation numbers. So you're going to see how that kind of works out. So here are some rules, and you might want to commit those to memory, all right? So it says the oxidation number of an atom for a free element is 0. What the heck does that mean? For an uncharged element by itself, so like just copper metal, carbon is charcoal. Oxidation is oxygen is O2, nitrogen is O2, neon. If it's a free element, it's a 0. There is no charge, there is no oxidation number. All right, next, it says that the oxidation number of a what? Of a monatomic. What does monatomic mean to you? All right, it means one atomed ion is equal to the charge. So here is sodium. Has a charge of +1, has an oxidation number of +1. Here's calcium with a charge, as I wrote it, of a +2. It has an oxidation number of a, 2+, has an oxidation number of a +2. Here is oxide with a charge of 2-. So oxygen has an oxidation number of a -2. Okay, so those are the monatomic ions. All right. Now, here are some very, very specific rules, okay? In compounds, oxygen has an oxidation number of -2, except for in peroxides where it is -1. All right, why do you think that is true? All right, why do you think oxygen is either -2 or -1 and nothing else? Well, it's the second most electronegative element there is. That's why. Okay. Um, I'll tell you. Oops. I'll tell you one thing. Number 3 does have an exception. And that's if you have oxygen with fluorine, and we'll get to that in a second. And compounds containing hydrogen, hydrogen has an oxidation number of +1. And again, we can probably find a few exceptions, but that's pretty much, the rule of thumb. Now look at number 5. Why is there an always in number 5? Because fluorine is the most electronegative element, and there's no exceptions to this. So fluorine is F2 be 0, and any other case, fluorine will always, no exceptions, be -1. So like in number 3 again, what if I put oxygen and fluorine together, F2O? All right, fluorine will be -1, and oxygen will then be a positive number. Okay, why is that? Because fluorine will have greater, control over those electrons, forcing oxygen to be on the positive end, won't it? And then finally, the next one says the sum of the oxidation states for an electrically neutral compound must be 0. So I can put a little like 6A in here. Okay, if you're talking about an ion, the sum of the oxidation states for an electrically non-neutral, like an ion, must equal that charge. Okay, so let's see how this works. Okay, so I'm actually going to go right to left or left to right here. So I'm not going to go down and then over again. I'm just going to do carbon dioxide and then this magnesium, whatever that is. All right, so let's see how I set this up. So I'm going to use number 6. There's no charge on here, is there? So I'm going to say carbon plus 2 oxygens will add up to 0. Now, what of those 2 elements do I know something about? Is there anything in the rules about carbon? And the answer is no. Is there something in the rules about oxygen? And the answer is yes. All right. So I'm going to start off assuming oxygen is -2, because that's what it said up in rule number 3, that oxygen will be -2, except for the peroxide. I don't think CO2 is a peroxide. It's carbon dioxide, not carbon peroxide, right? So now do your math. This adds up to -4. So carbon minus 4 equals 0. So what's the oxidation of carbon? It will be +4. How did I do that? I added both sides, all right, to +4. So the oxidation number of carbon is +4, and each oxygen is -2. And what does that tell me? Carbon is on the positive end. All right, why? Because it's with these highly electronegative oxygens. All right, so if they're the negatives, carbon must be a positive. Okay, so what about letter F? Let's go over there first. Well, it's neutral, so I'm going to use number 6. Okay, so I have 2 magnesiums and 2 phosphoruses and 7 oxygens, and they all add up to 0. Well, what is something that I know about? Well, look at rule number 2. Magnesium by itself, this is an ionic compound, what would be the charge of magnesium? Isn't it always +2? Or I should say, isn't it always 2+? So what's the oxidation number of magnesium? It's +2. I don't know anything about phosphorus, but here we go. Here's oxygen. I'm going to assume it's going to be -2. All right, so here is that. And now what? Well, let's do some math. What's 2 plus or times 2? It's going to be +4 plus 2 phosphoruses. And what's 7 times -2? Well, it's -14, right? So I'm going to put this here. Here's my math. So what's 4 minus 14? Looks like 10. Why am I having issues? Come here. There we go. All right, so let's try this. So I added that -10 to both sides, and now phosphorus is +5. All right. Why would phosphorus be a positive? Because I have 7 negative oxygens. All right, that's a lot of negatives. Phosphorus and magnesium need to be positive. Okay. Let's try the next set. Okay. So what am I saying? Sulfur hexafluoride. All right, it's neutral, so I'm gonna do this. And do I know anything about sulfur? Sulfur in my rules? No, it's not. Is fluorine in my rules? Yes, it is. What will fluorine always be if it's not in its elemental state? It is going to be -1. So sulfur minus 6 equals 0. Therefore, sulfur is +6. Why don't you try letter G on your own? It's one of the easier ones. Go ahead and try that. Pause this. Do it. Okay, welcome back. Hopefully you got something good. So here's my sodium plus bismuth plus 3 oxygens. Do I know anything about sodium? Yes, it's a monatomic ion. Do I know anything about bismuth? No, I don't. All right. Do I know anything about oxygen? Yes, I do. It's -2. So I can do this. So what is +1 minus 6? I believe it is -5. So add a +5 to both sides, and I get bismuth has an oxidation number of +5. Okay. Now, what's a little bit different about nitrate? There's a charge. So do you remember what I told you about like a 6A rule? If it's not an electrically neutral compound, it's an ion, that the oxidation numbers have to add up to the charge of that ion. So here, notice that nitrogen plus 3 oxygens equals -1. Where'd that come from? It came from the charge of the nitrate. All right, so now I have nitrogen plus 3 oxygens is equal to -1. So I'm going to add 6 to both sides. So nitrogen equals +5. Letter H is a little bit crazy. All right, you'll see why. So iron is not an always, it's wishy-washy. I don't know the charge, so I can't call it a monatomic ion. All right, so I'm going to find out what it is. But do you know what oxygen is? Well, sure, oxygen is -2. Okay, so let's add 8 to both sides and then divide by 3, and you get a really bizarre answer. It's the right answer, but it's still pretty bizarre. All right, you get 8/3. All right, so yes, that means that oxidation numbers can be fractions. A little bit different, isn't it? All right, let's try U2O. No, but I did it wrong, UO2. There we go. Whew. So you can do that on your own. Go ahead and do that one. All right, hopefully you got something like this, and I got uranium being +4. Okay. What about chlorine? Hopefully this is easy. It's element state. It's 0. If you don't believe me, I did something like this. 2 chlorines equals 0. Therefore, chlorine must be equal to 0. All right, it's in its elemental state. Now watch really closely on how I do letter E. Okay, so start off by watching me. Don't write this down yet. All right, or if you, I guess you can if you want. All right, so I'm going to do this. And I'm going to make my regular assumption, okay? And then what? Okay, 2K equals 4. And then what happens? K equals 2. Think about it. What's the charge of potassium always? Always +1, right? It can't be a +2 because that's not its monatomic, all right? So you can't do this, all right? I'm gonna put my little X there. You can't do it that way. So I made a mistake. You can't use this. You can't use oxygen as a -2. So I'm gonna start again. So in this case, I'm going to use my monatomic ion. So 2 plus 2 oxygens equals 0. I'm going to subtract 2 from both sides, and oxygen is going to equal -1. I'll put it over here. So what does that mean? Oxygen is the peroxide. All right, oxygen is the peroxide. So notice how this is written funny anyway. Maybe it's a clue to you that, all right, there's something going on here. So wouldn't it be KO otherwise? It's kind of weird, isn't it? This is actually called potassium peroxide. And if you remember the elements, or excuse me, the ions, you're supposed to memorize, peroxide is O2, the -2 charge. That means each oxygen has an oxidation number of -1. All right, so notice how I figured that this was a peroxide. I tried it with using -2 and it just didn't work. Potassium can never be an oxidation number of a +2. Why? Because potassium's charge as an ion is always 1+. All right, so that's how I knew I had to go back and try it again. All right, let's try this last one. Why don't you go ahead and try this last one and see what you get. All right, so I got this first, and I'm going to try oxygen as -2 again. And notice that chromium is a wishy-washy, it is not an always monatomic, so oxygen will be a -2. If you have a peroxide is very unstable, and it does not like to be in the -1 state. But if it's forced into it because of the potassium, it has no option. But if you have a wishy-washy chromium, it will never be a peroxide. okay? So I'm going to keep going here. So my assumption's pretty good. And then what do you end up with chromium? You end up with a chromium being +6, okay? So that's how you do oxidation numbers, okay? Let's go to the next page. All right, this is kind of the important part, okay? It is, you had to know how to assign oxidation numbers to do what really counts here, okay? So you have to identify redox reactions. Not every reaction is a redox. So what you need to do is assign oxidation numbers to all elements. If the oxidation number changes, it's a redox reaction. If all the oxidation numbers remain the same, it is not a redox reaction, okay? So let's find this out. What is the oxidation number of carbon? Notice it's elemental carbon. So that's really your first rule. What's the rule number 1 on the prior page? What will be the oxidation number of elemental carbon? It is 0. What about elemental sulfur? It is 0. Now, what do I do with carbon and sulfur? All right, carbon is actually closer to being a metalloid. It can be a positive or negative in a way. So I would go with sulfur. What is sulfide? That is your monatomic ion, isn't it? So what is the charge of sulfide? It is -2. So now what? Go ahead and figure out what is the oxidation number of carbon. Do it just like we did on the prior page. Set up your equation and solve for carbon. Go ahead and do that real quick. Did you get +4? That's what I got. So the question is this a redox reaction? Well, yes, carbon went from 0 to +4. Sulfur went from 0 to -2. So now what is being oxidized? What's being reduced? I brought back Leo goes Gur. All right, so Leo, lose electrons oxidation. All right, which oxidation number went up? If you said carbon, you're right. All right, and for me personally, I think of reduction. To me, it's easier to see because to me, reduces means it gets smaller. So which oxidation number got smaller? That is sulfur. So normally you think of oxidation first and then reduction because that's how it's written. But I look for the reduction first because that's when I see that's the one that's going down. So then the other one going up must be the oxidation. Okay. So let's look at number 37. What are we going to do? All right, for the following reactions, assign oxidation numbers, determine which atoms are being oxidized or reduced, if any. It may not be a redox reaction, who knows? All right, so let's try this. What would be the oxidation number of magnesium as a metal, as an element? Hopefully you remembered what we said, rule number 1, it's a 0. Okay, well, what was rule number 2? All right, nope, wrong one. What was the one about oxygen? I forgot the one was oxygen, okay? What was the rule for oxygen? It must be as either peroxide, be -1, but when is it most of the time? It's -2. So if it's with water, all right, it's always gonna be -2. And the hydrogen will always be +1. So that's easy. So that will always, always, always be true for water. So there's not a lot of like guesswork there, okay? All right, what about magnesium? It's a monatomic ion. Well, what's the charge of magnesium? The charge is +2, or 2 plus, I should say. So the oxidation number is +2. And well, guess what? Oxygen, again, is -2. Hydrogen is +1. Okay, that didn't change. But what about hydrogen? It's all by itself. It's not in a compound. So it's in an elemental state. It must be 0. So look at these numbers. Did any of these numbers change? The answer is yes. So which numbers change? So look at magnesium. Went from magnesium 2 plus. The oxidation number went up. So what does that mean? Magnesium was oxidized. That's right. Okay, so then what got reduced? Well, hydrogen went from +1 to +1 here, but wait a minute, what did hydrogen do over here? Went from +1 and went down to 0. So it got reduced. Not all the hydrogens changed oxidation number. Some of them did. Some remained as hydroxide. So it's still going to be redox. So let's go ahead and look at the next one. So this is a combustion reaction, okay? And so combustion reactions are always going to be redox, okay? So let's kind of find some things that are kind of easy. I see O2. What will O2 always be? 0. What did I promise you about water? Hydrogen will always be +1 and oxygen will always be +2. All right, so I'm looking at methane, CH4. All right, I know that hydrogen will always be +1. So what about carbon? Can you go ahead and figure out what carbon is? Go ahead and do that right now. Did you get -4? All right, so if you needed to set up that equation like we did with the last page, and you say like 1 carbon plus 4 hydrogens equal to 0, 1 carbon plus 4 times +1 equals 0, so carbon equals -4, doesn't it? Okay, do the same thing with carbon and carbon dioxide. We know that oxygen is going to be -2, so what will carbon be? I hope you got +4. All right, so what changed? All right, hydrogen did not change, did it? All right, so what about carbon? Did carbon change? Yeah, it went from -4 up to +4. So we say that carbon's been oxidized. What got reduced? Well, the oxygen went from 0 to -2, didn't it? All right, why don't you do the next one all by yourself and see how you do? Pause this, do it. All right, well, you know what? Here's methane again, and it didn't change. It's going to be -4 and +1. You already did the work up in this problem, didn't you? And here's water. It's +1 and -2, so that doesn't change. So, oh, I can look at hydrogen by itself. It's going to be a 0, isn't it? So now we're left with carbon monoxide. Well, what will oxygen be? -2. So what must carbon be? +2. All right. So what changed? Carbon went from -4 to +2. So once again, oxygen or carbon was oxidized. But did oxygen get reduced the way it did last time? No, it's still -2 and -2. But look at hydrogen. It went from +1 to 0. So hydrogen got reduced. All right, can you do the last one for me and see what you get? Go for it. Pause this. I mean it. Hit the pause button now. All right, so I see this is a monatomic ion, +1. I'm going to go over to water because it's super duper easy. All right, and there we go. What about oxygen in chromate? I'm going to put that as -2. I put oxygen over here as -2. So did you do the math? What did you find out the chromium was in chromate? Isn't it a +6? Does that make sense? 6 times -8, or sorry, 6 plus -8, isn't that -2? And what about over here in dichromate? Isn't 2 times 6, 12, minus 14, isn't that also -2? So did anything change? And the answer is no, it did not. So is this a redox reaction? The answer is no, it is not a redox, okay? So I'm going to stop here, and there will be a part 2 coming up, all right? So again, don't wait to be great. Take your time going through some of this stuff, and make sure you always follow the rules. Take care. See you shortly. Bye-bye.